All right, so today starts basically for the most of the rest of the chapter all about surface area and volume. Now, we're going to break the first couple sections into 2 days because we're going to talk about surface area of one figure and then surface area of another, okay? Now, this is, again, remember in section 12.1, we talked about how we have a formula list. We're going to add a lot more to our list.
Yeah, so far you have one.
We have Euler's theorem. Okay, that's the only one so far. The rest of them all involve surface area and volume. Okay, we're going to first focus on surface area of all these different solids, and then we're going to talk about volume. All right? In the end, there are 5 different solids we're going to be finding surface area and volume of. So that means 10 formulas, okay? So just kind of keep that in mind.
10 just for surface area and volume, plus the other things that we're going to be talking about too.
Okay, so just really stressing that, making that formula list, okay? Now, before we get to some of these things, I want you to keep in mind that when you are dealing with finding the surface area volume, you need to know what figure you're dealing with, okay? So today we're going to focus strictly on a prism, all right? Now, this is actually probably a vocab term you're familiar with, okay? There are lots of prisms out there. Now, what exactly is a definition of prism? Notice it's a polyhedron. Now, what is a polyhedron again?
We talked about that being, it's bounded by polygons, but it is a 3-dimensional figure.
So it's 3-dimensional and it has polygons. So all polygons that make up it. Now, there's some criteria that also happen because it's a prism. Now, in this polyhedron, they're going to have 2 congruent faces, and we call those the bases. So in a polyhedron, there's all the faces are polygons, but 2 of them have to be for sure congruent to each other, and those are what we call bases.
And you may have others that are congruent, but you have
these are the 2, yes. And these are 2, these kind of tell you more about the prism. All right, and these lie in parallel points, okay? So kind of imagine what that looks like, parallel to each other. We're going to see some examples in just a minute. Now, the reason why you need to understand what a base is, notice right here, it says prisms are named after their bases. So depending on the shape of their base, so if the base is a triangle,
then it would be a triangular prism.
Triangular prism, exactly, okay? Now, some other vocabulary. Lateral faces. Now, we know faces of a polyhedron or prism, because that's what we're focusing on, are all of the polygons.
Right.
Okay, now lateral faces are basically the faces that are not bases. All right, so the bases have an actual name, lateral faces are the rest of the stuff. Now, these are always parallelograms, and these are formed by connecting, notice, the corresponding vertices of the bases. Again, when we show you a visual of this, this is all going to make sense, okay? Right now, it's just a bunch of words. Now, the segments that connect, I'm going to kind of start this. The segments that connect the vertices are called lateral edges. So, you have your bases. When you connect the bases, the corresponding vertices of the bases, those are called lateral edges. Okay, so when you connect the corresponding vertices, you're going to have
one base to the
from
next.
one base to the next. Those are your lateral edges. Basically, lateral edges are the sides of all the lateral faces. Okay. All right. Last word, vocab on this particular slide: altitude or height. Now, we've seen those words before. When you think about altitude or height, you're thinking perpendicular, right?
Right.
And it's the perpendicular distance between the 2 bases. Okay. So how far apart are their 2 bases? The height. Again, key here is it has to be perpendicular. Okay.
All right.
All right. Some more vocab.
Okay, so we've talked about the idea of right and oblique a little bit before. I don't know if we've gotten into oblique. We've talked about right.
Yeah.
We've talked about right before. So to be a right prism, it's going to be a prism whose lateral edges are perpendicular to both bases. So to be right, that means that if I look at the lateral edge, so the edge that connects one base to another base, that edge, it's the side of 2 of the lateral faces, that base should be perpendicular to both bases.
Okay.
That's what makes it right.
Okay.
Now, oblique, this word is talking about when you have a prism whose lateral edges are not perpendicular to the bases.
So just kind of the opposite.
They're slanted. And, you know, in class, I used to always show kind of if you have a slinky, slinky stands straight up and down, but you can kind of, if you slide the
Tilt
top
it a
part
little
over, you start to see that oblique edge where it's a slant height. It's not going to be a true, the height of the prism, which we're going to get to in a second. The slant height would be basically the length of the oblique lateral edge, where it's not the actual height. The actual height is always going to be perpendicular to both bases.
Okay, and guys, the height is more important with prisms versus slant height. You're going to see this word slant height again with some other solids out there, but height's kind of the key. So just really kind of keep that in mind.
Yeah. So just 2 words to focus on. We have right, which means that basically that it's got straight side, like
most things are right.
What you're going to see. But we'll have right, and then we'll have oblique when you see that it looks like it started to be slanted instead of straight up and down.
Now, before you move on, I want to go back to that right prism because that's what we're going to see most of them.
Yes.
Now, because I want to stress here, just a little thing, to kind of tie something. We know that in a right prism or any prisms, the lateral faces are parallelograms, right?
Right.
So if it's a right prism, what kind of parallelograms would those lateral faces be?
Well, they'll definitely be rectangles.
So that's something to kind of keep in mind. So in a right prism, all the lateral faces,
so that's these pieces right here,
are going to be rectangles. In oblique, they're just parallelograms.
Right.
Okay? So something to kind of keep in mind. All right?
Love it. Good thing to point out.
All right. So our whole point of all this vocabulary is to get to this idea of a surface area. Now, surface area is just finding the area of all of the surfaces.
Right.
Think about it that way. Now, it really is the sum of all the areas of its faces. Now, faces of a polyhedron are what?
All polygons.
So it's basically finding the area of every single polygon that makes up that polyhedron and adding them all together.
Right.
Okay? So you could break it up to all those and then add them together. Now, we're going to learn some quicker ways of doing it.
And you guys probably with surface area, you've talked before in middle school about like wrapping up a soup can or, wrapping paper around a present.
So those are anything
idea of surface area.
That's a surface area. Now, surface area is a 2-dimensional thing because it's dealing with area. It's what covers the 3-dimensional shape, okay? Now, lateral area is basically just the sum of the areas of its lateral faces. So without the bases.
And which this is really common when you think about, like, for example, I know it's not a prism, but a soup can.
Yes.
Because you wrap a soup can label around just the lateral part of it, but not on the bases.
Exactly. Now, a good way to kind of visualize surface area, because surface area essentially is 2-dimensional, is to create a net. A net is a 2-dimensional representation of all the faces. So it's like taking something and flattening it out. Okay.
Yeah, and a lot of times you might do that with like cardboard boxes. When we're done with a Kleenex box, we try to flatten it so it fits in the trash can better.
Exactly.
And you can open it up and actually see the net.
Exactly. That's how it's created. A lot of those 3-dimensional things, like the Kleenex box, is created by a net. Okay. Now, this here, I'm going to talk about. This is going to lead us into the surface area of a prism. All right.
Formula.
Yes. This right here is a net. So it's 2-dimensional representation of, now when we name this, we're going to name it by its bases. Okay, so what do you think the bases are?
The bases are the 2 congruent
faces
that are in this thing. And I would say that those are going to be the pentagons.
And basically, guys, if you see a shape other than a rectangle, then that's the basis. Okay, so this is a pentagon base. Now, this is also a right prism. So how I would say it would be a right. And I've heard, how would you say this?
I would say pentagonal.
That's what I was going to say. Sometimes it's kind of tricky to say that one. Prism.
I always have students that say pentagonal.
Pentagonal.
Pentagonal, I think is how
it's more appropriate.
Way to say it, but we won't care.
No, it's not going to be picky. Okay, so this is a right pentagonal, if I can even say it, prism. All right, so we're going to find the surface area. Surface area, and the book likes to use capital S. You can say capital S-A. I'm just going to use S since that's what the book does. It's basically sum of all of its faces. So we would need to find the area of what things?
2 pentagons.
The 2 pentagons. Now, I'm going to call this, instead of just pentagons, I'm going to call
it
the base, and I'm going to call it even a capital B for the area of the bases. All right?
Okay.
So this is going to be the area of a base, or base area. So we're going to have two base areas. Okay?
Okay. And that's something you'll see in all these formulas, that big B. Just get comfortable.
Yeah,
the area of the base.
The little b is always a base length, a segment length. Capital B is talking about anything that's capital, usually is area or perimeter or whatever. Now, the rest that's left is your lateral area. Okay, so I'm going to make a little note. All of this stuff is your lateral area. Again, using this vocabulary. All right? Now, notice, because this is a right prism, all of the lateral faces are rectangles. We talked about that just a minute ago. Now, if I find the area of one, I can just kind of then multiply it all, or just find one big chunk. This is one big rectangle. You seeing this?
I see this.
All right. Now, how do you find the area of any rectangle?
Base times height.
Base times height. Now, not base area. Base is, okay. Now, here's the deal. I'm going to talk about that height. The height of this figure right here, all right, is actually the height of the prism. Notice, and anywhere I draw this, it is the perpendicular distance between your two bases.
Okay.
So this is your height. Now, what would this be? This is the whole base of this rectangle, but think about it comes from all these individual segments.
Yeah, and I'm just thinking that when I fold this all up,
kind of wrap it
around that pentagon, there's those 5 sides of the pentagon. It's really the perimeter of the pentagon.
Yes. So this whole base is the perimeter of your base, in a sense. So to find the area of this whole thing, you said take base times height. Well, the base of this actually ends up being the perimeter of your base, okay, times the height. All right.
All right.
So that's kind of what we're going to see. So basically on the next slide.
Really, I just need to know specifics about my base and the height.
So let's just go to that real quick. Let's kind of remember that. So what is the capital B? This is the surface area of a right prism. So you might want to make a note of this. The capital B
represents the area of the base.
Area of the base. And I love what Miss Huckerby just said. I'm going to have her say that again. The capital P stands for?
The perimeter.
Of what?
Of the base.
And what's the H stand for?
The H represents just the height.
The height of the prism. Okay. And I'm stressing that because you sometimes will have a height of the base. It's not the same as the prism. Now, notice, like you said, I want you to say that again.
Just that basically all you need to know is everything. You need to know pieces about the base.
Yes.
And you need to know the height of the prism.
So if
you don't really need to know anything else about the lateral edges or lateral parts at all, lateral faces.
Yes, you do need to know the lateral edge.
Lateral edge.
Because the height of the prism, and I'm just going to make a note, because this is a right prism, this is a lateral edge. So I like that you even said that, because that kind of reminded me of that. Okay, so again, if you know the base area and you know the perimeter of the base, so again, both involving the base, okay, this both involves the base. Then you can also, or then knowing the height of the prism, you can find the surface area. So this finds the surface area of the whole right prism.
Now, one thing to keep in mind, guys, this is true for right prisms. There are prisms that are not right prisms, but you can always just find the areas of all of the faces and add them together. That's kind of the basic idea of surface area. We just want to be able to take it a step further because we're going to be looking at some right prisms that would be a little bit trickier to do that for, and we're trying to come up with some easier ways to get there.
And I will tell you guys, most of the problems, I would say majority of these are right prisms.
Right.
If you're doing with it, just because we are going to be more involved. So this is allowing us to do a little bit quicker. Again, guys, you can break it down and flatten the prism out and look at each individual surface and add up all of those areas, and you'll still get the same outcome. This just allows you to do it a little bit more condensed.
Right.
Okay, so what we're going to do is we're going to try some examples. And I want to stress, guys, again, what Ms. Huckerby just said. A lot of it, 2 of the 3 unknowns. Notice 2 of the 3 unknowns involve the base. So that right away is something I always stress. Think about what the base is. Maybe even draw a picture of just the base. You don't need to draw the whole prism. Just focusing on that. Okay?
Okay. So let's take a look at some examples. This first example says we're going to find the surface area, which is going to be a common theme we're going to be doing here, of a right rectangular prism. Now I'm just going to stop right there because I want to clarify, what does it mean when I say it's a right rectangular prism?
Well, does that mean we have a right rectangle?
It's not a right rectangle. Well, all rectangles hopefully are considered right. I guess they have bases that are.
But the reason why I say that, because if you have a triangular prism, you may not be a right triangle. So that right is saying the prism is a right prism.
Yes.
So that goes
right
along.
Prism.
Okay. And then we know that based on that second word of a rectangular, that means the base is rectangle. So rectangle base.
Love it. And it's a prism. Okay. With a height of 2 feet, we know we need that piece.
So the height, I'm just going to, just say h equals 2.
H equals 2. Love it. And a length of 5 feet and a width of 4 feet. Now, what is the length and the width referring to?
Well, because the base is a rectangle, that probably involves the base.
Exactly.
So I love it. I was going to say, let's draw a picture. And guys, here's the deal. We're not saying you have to draw every single time. But if you're going to draw something, draw the base. Don't feel like you have to draw the whole entire prism. I actually rarely do, just because it takes some time.
Okay? And it's hard to draw three-dimensional figures. Okay, so there's really, first of all, let's just write down what was our formula again when we're trying to find surface area.
So it's 2 capital B plus capital PH. And again, 2 base areas, because there's 2 congruent bases, plus the perimeter of the base times the height.
Love it.
And again, writing down that formula, guys, helps you remember the formula.
And I'll tell you, we'll probably do this for every single question.
Yeah.
And I would encourage you to do this for every single question. In fact, on your test and on your quiz, you're going to get a point for knowing the correct formula.
Yes.
So write the formula for every single question.
All right.
Okay. We already know the height. That's awesome. We don't know the pieces about the base yet. We don't know the area of the base, and we don't know the perimeter yet.
Okay.
Not too hard to find for a rectangle. So let's find our big B. Let's find our area of our base.
So that's just going to be length times width, so 5 times 4, so that's 20.
Uh-huh.
All right.
And what about
and
the
then
perimeter
of the base. So I can say 2 times the 5 plus 4. So 2 lengths, 2 widths. All right, so that's going to be 18.
Wonderful. So let's go ahead and let's put these pieces into our formula. So surface area, we said 2 area of the bases, so 2 times our 20, plus that perimeter times our 2, our height.
That seems easy enough.
That's easy enough, exactly. Now let's go ahead and let's simplify. So 2 times 20,
40.
And 18 times 2,
36.
And when we add these together, that surface area will be
a 76, and this is square feet because it's area.
Good deal. Love it. That's all there is to it. Now, could I have drawn this beautiful rectangular prism? Sure. Don't need to.
I actually don't. I recommend.
Very
okay.
rarely.
Now, this one actually has a picture for you. All right. So, when the picture's already there for you, again, don't feel like you have to redraw it. If I was redrawing something, what would you recommend redrawing?
The base.
Okay, so I might actually do that just to kind of get an idea. So let's talk about it. It just says find the surface area of a right prism. So here's the deal. They're not telling you what kind of prism it is.
Oh.
So when they don't tell you, that means there's going to be a picture.
Out. Exactly.
So we do know it's a right prism and we're finding surface area. I'm going to write down that formula. Surface area equals 2
big B plus perimeter times height.
Okay.
Now, I'm looking at this one, and I know a common thing that kids will do is they will see a height of 6 in there, and they'll think that's the height of the prism.
Yeah.
And here's the thing. One thing that Mrs. Palermo mentioned a while back was that when you're looking at all the lateral faces, they will always make parallelograms. And if it's right, they're always going to make rectangles. I'm looking at this one, and I know that that piece out front that has a height of 6 is a trapezoid.
So what does that mean?
That means that that has to be the base. It is not one of the faces.
Okay, and I love that how you said that. Here's the deal, guys. Base, often what people think is on the bottom. A lot of times I see people think that this little piece down here is the base, just because it's at the bottom. But that's
It's
not
not
the
congruent
case.
to the top either.
No, exactly. You want to keep in mind, and I like how you did that, it's based on what we know the other pieces should be. So if you see a figure like a trapezoid that we know is not a parallelogram, okay, or a rectangle, it has to be a rectangle, those lateral faces have to be rectangles, then we know that this is our base. So I'm going to redraw just the base. And again, you don't have to. And notice it's not just any trapezoids, it is an isosceles trapezoid.
Yeah.
You see that? So this height of 6 in there is not the height of the prism. It's the height of the base. Okay?
Right.
And we talked about that a little bit ago. All right. Now, they do give you this. This is considered a base edge in a sense because it's part of the edge of a base. So this is 12. Now, do I know anything else on this
We do,
trapezoid?
because we know that the two bases are going to be congruent. And on the back base, you'll see that the sides are 3 radical 5.
So the little congruent, the legs of them basically.
And the top edge is 6.
All right. Now, here's the deal. We need to know the base area, so we got to figure out how to find the area of a trapezoid. And I need to know the perimeter of the base, which is just adding up all the sides, which we have them now. And I need to find the height of the prism. Now, we already said that this isn't the height of the prism. So where do we find the height of a prism?
The height of the prism is, again, and if it's a right prism, it's going to be just a lateral edge.
Which in this case would be?
Going from one base to the other, the 4.
So this right here is your height. Okay? So we know the height is 4. I love that you said it's a lateral edge because it's a right prism. Okay. So we have this piece. Now we just need to focus on the base area and the perimeter.
Okay.
Now, trapezoid area.
Yes, here we go.
How do we find the area, and I'm just going to write this off to the side, of a trapezoid?
Well, we know that we need to do basically the average of the bases times the height. It's add those two bases together.
So the two bases, I'm just going to write this for me. So the
B1 plus B2.
two bases.
I always write divided by 2.
Okay.
But you could write half of that.
I like that.
Times the height.
And then just times this by
Height.
height. Okay.
That'll work.
All right. So if I was going to find the base area, all right, average the bases. So it would be
6 plus 12 divided by 2.
And then
Times our 6. That's our height.
So that's going to be 18 divided by 2, which is
9
times 6.
So 54. Yeah.
All right. So there's that piece. Now what's left is the perimeter.
The perimeter, yeah.
Okay. So how are we going to find the perimeter?
So we want to add up all the sides. So we've got our 6 plus our 12. I'm going to go with the easy parts first. And then plus the 3 radical 5 and another 3 radical 5.
And you could write it as 2 times the 3 radical 5, or just write it like this. So add this. Can I add all of these terms together?
I can only combine like terms, and those pieces that have the radicals are like radicals, so I can combine them with each other, but not with the 18.
So you can't put 18 plus 6 and then put radical 5. So it would be 18 plus 6 radical 5. All right, now I'm going to leave it exact for right now.
Okay.
I mean, we could type this in our calculator and use a rounded answer in just a minute. Whatever, okay? So we have the perimeter. All right, it's kind of what you're comfortable with.
Yeah.
All right, so find the surface area. We're going to put it all together. 2 times the base area, so that's 54. And then we're going to add in the perimeter, which is 18 plus 6 radical 5 times the height, which is, what did we say the height was?
The height was, the height of the thing, the whole prism was 4, sorry.
Yeah.
Yeah.
Okay, so here's the deal, guys. You could, again, however you do this, you could, because there's units, we could go ahead and round this first, all right? It's up to you. What do you want to do?
I'm going to leave it as exact as possible.
Okay.
So I'm going to just say, okay, the 2 times 54 is going to give us 108. And if I type in my calculator, 18 plus my 6 radical 5, and I'm going to hit equals first before I hit times 4, just so I know I'm not goofing anything up. That's going to give me about 125.67. But I'm going to leave the big long decimal in my calculator and just say plus 108 to get my 233.67 centimeters. Squared, thank you. Squared centimeters, yes.
Now, again, guys, you could, if you wanted to, you could distribute that 4 through and then get more of, if you needed an exact
Simplified answer, yeah.
But since there's units, we can go ahead and round.
Right.
And you can type this in as soon as you can, okay? So again, notice, guys, the work involved in this. It's not just putting some numbers in. You're showing, notice all this work down below here.
Yeah.
Okay, I'm stressing that because there's some of you that are kind of getting skimpy on that work lately. You're showing me how you're getting the base area, how you're getting the perimeter base, and then you're substituting in. Communicate so we can kind of follow what your ideas are, okay?
All right.
One more question.
All right, this one, no picture again. So it may be helpful just to be thinking of what this shape looks like, and maybe we'll draw some bases here. It says we're going to find the surface area again of a right triangular prism. So let's talk about it. What does that mean?
Does that mean the triangle is right?
It is not a right triangle.
Well, it could be.
Could be. We don't know.
But we just know the prism's right.
Yes.
And we have a triangular base.
Love it. Okay. We have a height of 4 feet. That's referring to
the height of the prism.
And the regular triangle. Ooh. What is a regular triangle?
Well, that means that it's an equilateral triangle, and that's talking about the base.
Yeah. Don't forget, to be regular, it has to be equilateral and equiangular, which in a triangle, both will happen. It has a side length of 6 feet. So I'm going to just draw the base. Oh, that's a really beautiful triangle right here. Okay. It's equilateral, so we know all the sides are congruent, and they all are 6. Okay. We know surface area. What's that formula again, Mrs. Palermo?
Okay, it's surface area equals 2 times the base area plus perimeter of the base times the height of the prism.
Love it. Okay, so let's see what things we do know right now. We do know the what?
We know the height of the prism.
So we know the height right here is going to be 4 because that's what they told us about the height.
And guys, a lot of the times they will give you the height of the prism.
Yeah.
Pretty easy to find it. If they don't, that means you're probably having to find it. So
right. Do we know the area of the base yet?
No.
Okay, so we need to find the area of the base. Do we know the perimeter of the base?
No.
But that's going to be pretty easy to find too.
We can find both of those things.
All right, so those are the 2 things we need to find. So area of the base. This is an equilateral triangle. We learned a formula.
Yes.
To help us to find the area of an equilateral triangle.
That's that 1/4 side squared. So it would be 6 squared, radical 3. So 1/4 6 squared times radical 3. So we do, that would be 1/4 of 36, radical 3. So it would be 9 radical 3. And I'm just going to have you leave it like that for right now.
I love that.
Even though there's units.
We know we're going to get, a decimal answer in the end. All right. What about the perimeter?
Well, you just do 3 times 6.
Yeah.
So that's
nice
18.
Thing. Okay. So let's rewrite our formula with all the pieces that we know. So surface area is going to equal 2 times the area of the base, which we said was a 9 radical 3, plus the perimeter times our height. Now, if we didn't have units, we could make this more exact.
Let's
simplify it a little bit.
Let's do that.
Okay.
That's going to be 18 radical 3. And then that's going to get you 72.
Now, could I combine those?
No.
So this right here is my exact answer. If you notice there's not units, you could leave it exact. But let's go ahead and let's type that in our calculator
now,
and figure out.
when you type it in, you got to be careful, okay? So when you type in the square root or the 18 radical 3, either just go ahead and push enter and then plus 72, or close parentheses first, because that when you put that radical, there's that parentheses, and then you got to close it. Push then plus 72, and then push enter, and you have about 103.18 square feet.
Love it. And again, we know we're talking about square feet because we're talking about area.